Alright, muchachos. So in the previous video, we briefly glanced over the how to design data recipe. In this video, we're going to go slow motion. You're going to see it in all its glorious details, in action, and what further implications it has on how you'll be solving problems going forward. Alright? But the main point here is that the structure of the data will drive the design of the code. And we can sort of see it in this example right here. So we take this image to be the structure of the data. There's a sort of visual similarity here with the code right here. So above, beside, right? So this square 32 solid red is in the top left corner of this code block. And we can see the same with this image right here, right? With this square 32 solid black on the top right of this code block, we can see the visual correspondence here also, all right? So what we'll see is that just by focusing on the data, we'll be able to derive 60% or more of the code. And this is where laying out templates will start to shine. All right, so we're going to do problems 4.0 to 4.03 because they're all related. All right. So anywho, let's just get started with 4.0, failing num. So in this problem, there are 4 subproblems, well, 3 subproblems, and let's just get started. So with the first one, I'm going to give myself some space here. So a number grade is often written in red to indicate performance on an assignment, and it's a number between 0 to 100 inclusive. Follow the design recipe for data and write the data definitions for NumberGrade. All right, so that just means that we're going to do this half of the design recipe first, then this half later when we have functions that consume the data that we defined, right? This is all about really being as accurate as we can about the data. All right, so let's just start. So data description, right? What does this even mean? So we go back to the diagram right here. All right. So it means that we have to transition to the world of computers and pick something to represent the data as. So either a string, number, or boolean. In this case, we know it's a number, all right? So you're going to write a type comment in this style. So a number grade, all right? Because this is what it says here, all right? Is a non-negative number because it doesn't make sense for you to have a negative grade on your assignments, right? What does that even mean? All right? Between 0 to 100 inclusive. By the way, these square braces means we're going to include 100, and this one on the left means we're going to include 0. If these were parentheses, it means we're going to exclude 100, and vice versa for the other side. All right? So a number grade is a non-negative number between 0 to 100 inclusive on both ends. That is the first step done. All right? Next is the interpretation. So that means that we go back to the diagram again. We have to transition from the world of data back into the world of information, right? What, human world value does this data provide, right? So it's just another comment right below it, a short, description of what it means. So some cases, this is hard to write because this already describes it really quite well, but I'm just going to be a bit more verbose here, all right? For the sake of completeness. And all right, so it means how well you did on an assignment. Assignment 0 is worst, 100 is best. All right, so that's just that step done. Next is the data examples. So just write some definitions as to what it is. So we know that it's a non-negative number between 0 and 100. So I'm going to call this ng0, ng short for number grade. We know that it includes 0. We know that it includes 100 right here. And let's also do one sort of in the middle, all right? Admittedly, these examples are really boring, but as we go further in the course with trees and stuff, these would become a lot more interesting, all right? But anywho, this is just a parallel to the example step in the how to design functions, right? We really want you to write things down rather than hold it all in your head where it's just not going to hold well as problems scale. So that's the data example step done. Next, let's move on to the function template. All right. So the template is going to be called NumberGrade temp short for template. It's going to consume a number grade. All right. And produce, we don't know yet because this is just a template. So NumberGrade temp, we call the input variable ng, and we're going to do something to this ng, all right? We don't know what it is. It depends on what the function is going to do, all right? But no, this problem isn't asking for a function definition just yet, all right? All right, so you may, see something a little strange here on this line right here, the signature. It says it consumes a NumberGrade. So up till now, all the problems that we all did before consumed only the 3 base types, right? It only consumed either strings, numbers, booleans, and images, right? What we're seeing here is that we're creating a new type. It's called NumberGrade, and it is these sets of values right here. It's a non-negative number between 0 and 100, right? It's as if we sort of, pushed in a new type right here. And this is something that define struct does with compound data. It actually puts in the environment a new data type. But we're going to go over that a little later in the course. Right now, this is the sort of mental image you should be having. All right, so it's a NumberGrade. It consumes a NumberGrade. And what you're going to do when you see non-standard types, right, like this, you're going to have to go pull in the context, right? So NumberGrade, right, you're going to see in this course, you're going to see things that are non-standard types and go, what the heck's a NumberGrade? Go look up to where the data definition is, and you're going to see what it is and what it means, all right? So you can pull in the context that is relevant to solve the problem at hand. And I find this, very, it's a common occurrence when you're learning something, in a sense that, let's say you're learning chemistry or math or something for the first time, and they define something on like page 1, right? And you just, just read it briefly, and they use it again in like page 50. And then now you're like, oh shoot, I forgot what that meant. So you have to go back and trace the definition, right? Trace the definition to see what it meant, and then bring it back into your working contextual memory, and then finally sort of decode the meaning and understand the problem, right? And that's just something that you're going to have to do in this course as we go forward, all right? Okay. And you may be wondering, like, yeah, all these type comments, ugh. But these will help as we progress through the course, because the problem statement right here, they're going to be a lot more vague. In this problem statement, we're practically just giving you the data design recipe, right? The data, and you're just like plopping down and writing it in the style. In future problems, problem statements are going to be a lot more vague. They're going to be like, hey, just go make Pong. And, you're going to have to be able to extract all the data that is in the game Pong and write it in data definitions right here, so you don't hold it all in your head and blow up collapsing from like the weight of it all. All right? But anywho, let's just mark ourselves done for that step. So there we go. All right. So let's move on to the next problem. So 4.0b, give myself some space here. So use the data definitions you wrote above and design a failing num function that consumes a NumberGrade and produces whether or not the given NumberGrade is failing. Assume that 40 or below is failing. All right? So pause the video and try to work through this on your own. I'm going to go for spoilers in 3, 2, and 1. All right, so basically we're just going to do this half of the design recipe now. We already defined the data. Now it's time to write functions that operate on that data. So signature purpose stub, as always. So this function's name is called failing num, So failing num, produces, well, it consumes a NumberGrade, all right? So NumberGrade, and produces, whoops, my brain kind of just collapsed there. And produces whether or not the given NumberGrade is failing. All right, so whether or not, that sounds like a Boolean because there's only 2 possible values, right? You either pass or fail. So it's going to produce a Boolean. All right, there we go. So that's the signature next to the purpose. So produces true if 40 or below. Right, so next is the stub. So let's just do that very quickly. Failing num, and it consumes ng. All right, and produces false as this dummy value. I'm going to make this a one-liner. There we go. All right, so that's the first step done. Let me mark myself done for that. Next is the example step. So, check, expect. All right, so failing num of 40 should produce true. And then failing num of, let's see, 39 should also produce true, right? 39. all right, should produce true, but 41 should produce false because, you just barely passed or something. So 41 should be false. All right, and let's check like 100 or something, just to make this more clear. So 100 should also produce false. All right, so there we go. That's the example step done. So there we go. Next is the template. So it says from data. So this means that we can go look at the data definition and see if there's a template written for it. So NumberGrade right here. All right, that's the template up there. So again, I want to stress that this has to be the signature. If you write number, it's going to be wrong. All right. So there we go. We're going to take this template and we're going to delete the stub. Well, first we should run it actually against the examples just to make sure there are no typos. Almost forgot that step. So there we go. Looks like it fails, but hey, no missing parentheses or typos and stuff. So now let's just use this template. We're going to call it failing num. And it consumes an ng. All right. So this is all the scaffolding needed to solve this problem. Pause the video and try to work through the solution on your own. We'll go I'm going to spoil number 2 in 3, 2, and 1. All right. So we just basically want this to be less than 40. Right? So less than 40. There we go. So all the tests should pass. Yep. And one fails right here. So this is when it equals to 40. Oh, yeah, because if 40 or below. So 40 is inclusive. So we're just going to write this equal sign here. All right, and there we go. All right, cool. I'm going to hide this and mark myself done. Let's see, we did the template already. And we coded body, test review and refactor. So press Control-I. Just make sure everything's nicely spaced out and indented. And all right, so that is how to design functions, consuming the how to design data step. All right, so let's move on to the next problem called, let's see, 4.0c. All right, so grades in the USA sometimes use letters A, B, C, D, and F. Follow the designers before data and write the data definitions for letter grade this time. All right. So again, it just means that we're just going to do the top half of the design recipe for data only, all right? So for letter grade, it's going to be written in the style. So a letter grade is one of, all right, because it can be either A, B, or C, all right? So the string A, string B, and the string C. Let's see, what else? Was it like D, D and F? All right, D and F. All right, so next is the interpretations. So let me just mark myself done for the data description. All right, next is the interpretation step. So there we go. Interp, letters representing grade. It's kind of repeating the type name right here, but I'll come up with something better later. Grade. A is best, F is worst. All right. So that's the interpretation step done. All right, next are the examples. So this is a bit boring data, but let's just, define A to be the string A or something, just for completeness sake right here. So there we go. So I did examples, and the next is a template that processes this data. All right, so this is kind of important, right? Remember these structural similarities between code here, right? The structure of the data will drive the design of the code. Well, this is where this, kind of comes more into play. So when you have a data definition, that is the keyword of one of, right? And all the types are the same, right? These are all strings. This is called an enum, right? And enumeration. Enum for short. All right, so when you see this, the function template is going to be, let me write the signature first. So this will be LetterGrade. LetterGrade temp. Let's consume a LetterGrade and produce, we don't know yet because it's just a template. So LetterGrade grade temp. All right, so LG, that's what I'll name it as. All right, so when you see this one-up case, right, one of these set of values, you have to write a con that sort of matches this symmetrical appearance, right? So con, one for each case. So there are 1, 2, 3, 4, 5. So we need 5 cases in the con. 2, 3, 4, and 5. All right. And in each case, we need to distinguish which one it is, what we're given, the LG, and then do an operation based on what it is. All right. So in this case, it's going to be string equal, question mark, because they're all strings, right? A letter grade is one of these set of strings. So LG. So what happens if it's A? Oh. All right. And then same for the rest. ... We have to do something. We don't know what that is just yet. All right. So I'm just going to copy and paste this for the other ones. Make this a little faster. There we go. So A, B, C, and D, and then F. All right, so that is the template step done, and that is how to design data for enumerations. By the way, this one, the one that we just said earlier, is called an interval. All right. All right. Anywho, we're on to the next problem, failing letter, huh? All right, so let's look at the problem statement. So notice how the data design recipe is already done. So we can see that there are already some check marks here for the data step, and it's pulling in the letter grade that we did previously in 4.0, right? This step right over here, except it defined a lot more examples right over here. All right. All right. So use the data definition you wrote above and design a failing letter, function that consumes a letter grade and produces whether or not the given letter grade is a failing grade. Assume that D or below is failing. All right, so this seems pretty doable. So pause the video and try to work through it on your own. We'll go over spoilers in 3, 2, and 1. All right, so we got to design a function called failing letter, So we're always starting with a signature, purpose, and stub. So failing letter, consumes a letter grade. All right, and produces whether or not the given letter grade is a failing grade. So whether or not that sounds like a Boolean. All right, so next is the purpose. So produces true if given D or F. All right. Okay, so next is the stub. So failing letter, So LG is what I'm going to name it. W value can be false. All right, so next is the test. So check expect. Let's see, failing letter of, let's say, A, well, that's a passing grade, so that should be false. All right, next is B, C, D, and F for all 5 of the letter grades. So let's see, 1, 2, 3, 4, 5, right? So B is still false, C is still false, D is true, and F should be true. So true and true. Okay, there we go. So if I run this just to make sure that all the tests are failing, no typos, no parentheses missing. All right, good, they're all failing, but you have no other errors. All right. So let me mark myself done for all those steps. So there we go. So signature, purpose, stub, that was done. Examples are done. Template from data, we're going to do that right now. All right, so is there a letter grade template that we can use? Yes, there is. So let's just copy that down and use it. All right, I'm going to delete the stub now. There we go. All right, so I'm going to rename this to failing letter, All right, so now really pause the video because this should be all the scaffolding needed to solve the problem. We'll go spoiler number 2 in 3, 2, and 1. All right, so you can see that the example is just mapped down very straightforwardly. So false, and then B is also going to be false. Same with C and D. Well, not for D. D and F should be true. All right, so true and true. There we go. So we run this, all our examples, all our tests should pass. And so they do. So I'm just going to mark myself done for the code body. And there you go. Test, review, and refactor. Review all the steps, Control I to reformat, etc. So Control I. All right, everything's nicely indented. But there's one last thing to note is that we can simplify this problem. All right. So define failing num, failing letter, consumes LG. So we only care about D and F to produce true. And there's an operation OR on Booleans that will produce true if either one is true, right? And that pretty much is the simplification that we can do here. So we can do something like this. So this right there, and this right there. All right. And run this, and the test should still pass, right? So I'm gonna delete this, Control R to run it again, and all 5 of the tests still pass. All right, so just Control Z, just so you can see these two on the screen, right? So this is where, some sort of creativity and intuition comes here, right? You can always simplify a lot of problems, and it comes with experience. But really, what you should be doing initially to get a working program, just to make it work, is to copy the template and then plop it down and fill in the blanks, all right? And I know it sounds very mechanical and boring and etc., but it will at least get you to a working program, and you can always simplify that working program into a more simpler one like so, all right? And I know, right? It's like, I like to follow all these steps in this recipe and etc., but I mean, I went over this in the previous videos, right? When you're a beginner at anything, right? Let's say I'm a beginner baker, and I am a beginner baker. I never baked a cake or anything before in my life, right? I'm gonna get measuring cups. I'm gonna go get like half a cup of flour, a couple teaspoons of sugar, etc. I'm gonna measure everything. I'm gonna get a timer for something. I'm gonna make sure that everything is perfect. I'm gonna put it in the oven for the exact time. An expert with intuition will probably be able to do a lot more, in the sense that they'll be able to follow their sense, right? They're going to go, all right, I can, cut the flour for this texture. I can bake it in the oven at a higher temperature for this texture. I can add more sugar. Maybe I can add, some salt or something. And it's just like really, gut-based. And, yeah, that's pretty much it with the design recipe. You want to follow the recipe, and intuition comes at this step right here, right? The final step. So either these solutions are valid, or you don't have to simplify. Simplifying is just something that you're just going to gain from experience anyway, but you should try to after you're done following the mechanical steps, like so. All right, so I'm just going to go with the first solution, and let's just submit this two-handed. So let's see, what is this? 4.01. All right, so there we go, U. All right, and check submission, there we go. Let's just also submit the first one, failing num. So there we go, failing num. So this is 4.0 what? 4.0, there we go. All right, so let's just do the third one, and then we'll check our score. So bump starter. All right. So let's just scroll down to the problem statement. So 4.02, notice the design recipe for data is already done. As we can see, the steps are done, checked off above. So use the data definition you wrote above and design a bump up function that consumes a letter grade and produces a letter grade 1 rank above. All right, so pause the video and try to work through the problem on your own. We'll go over spoilers in 3, 2, and 1. All right, so let's see, we got to design a function called bump up that consumes a letter grade and produces a letter grade 1 rank above, right? So letter grade. All right, so next is the purpose statement. So produce a letter grade 1 rank above the given letter grade, all right? So next is the stub, so define bump up LG, and we're gonna say it produces a letter grade, so let's just pick any of these. So let's just say A, right? Just a dummy function, test examples. Speaking of which, let's do the examples. So expect bump up, all right? So bump up of A, you should still A, right? There's no rank higher than A, right? If you bump up a B, then you should expect to get an A, right? All right, so next is C. If we bump up your grade from a C, you should get a B. And if you bump up your grade from a D or F, a D should be producing a C. When given F, we should produce D. All right, we're just going to go one rank up the given rank. So F, D, D bumps up to C, C bumps up to B, B bumps up to A, and then A bumps up to A because there's nothing higher than an A, at least defined in this definition of what a letter grade is. Even though, I know there are A pluses and etc., but this problem, this data definition, explicitly rules that out. All right, so let's just run and make sure there are no typos, etc. There we go. So that's fine. No typos, no parentheses, etc. Missing parentheses. All right, so now let's just copy the template and use that. So there we go. All right, so now pause the video. Oh, I gotta rename this. And really try to work through the problem, because this should be all the scaffolding needed to go work towards the solution. I'm gonna go with spoilers in 3, 2, and 1. All right, so the examples kind of make it, very clear that A, if we're given A, we have to produce A. If we're given B, we have to produce A, according to the examples up there. All right, so there we go. Next is B, and then C, and then D. All right, F, if we're given F, we should produce D. If we're given D, we should produce C. C should produce B. B should produce A. And A should produce A. All right, so if we run the test, all tests pass. All right, so let me just mark myself done for this. Okay. And then, of course, Control-I to refactor and simplify this further. In this case, there's no way we can actually simplify this, really. Like, this is good enough. All right, so let's just submit this in handed. And let's say feeling letter. It's called bump up, actually. All right, so checking the website, we see that we have 4 out of 4, 5 out of 5, and 5 out of 5. But anywho, the main goals for this video is that the structure of the data will drive the design of the code. And we can see it here, right? The structure of the data is that LetterGrade is one of these 5 cases. Therefore, you have to have some, there's some visual correspondence here between the code and the data, in a sense that this data definition has 5 cases. It's one of these 5 cases. Therefore, you have to make a cond that distinguishes between these 5 cases, right? And does something accordingly. And you can always simplify afterwards, all right? We also learned about non-standard type definitions. So LetterGrade, it's going to consume a letter grade. It's not the 3 or 4 data types that come with Racket and that, we're familiar with. It's something that we created ourselves to be more specific, right? So therefore, you have to do some tracing and bring that back into your working memory. And we've also learned how to fully follow the how to design functions recipe in all its glory. All right. Thank you for watching, human. If you wish to interact with more of your kind, join our Discord linked in the description or on screen. If you want to aid in my quest for world domination, consider hitting the sub button. Thumbs up if you enjoyed it, thumbs down if you didn't. Any questions, comments, or suggestions, fire away below. Also, check out the annotations on screen for the next relevant video.